The predictor system implements an advanced analysis called confidence analysis. Most fault signatures are a family of spectral peaks, often a harmonic set, sometimes with sidebands. Confidence analysis is a pattern recognition technique that quantifies the similarity of the measured peaks in a spectrum to the expected peaks. The confidence provides a strong indicator of whether a set of spectral peaks represents a real fault. If the confidence is low, it most likely means that the specific fault is not present. A high confidence indicates that the fault is likely real. Confidence is a measure of the probability of the presence of a fault, not the degree of severity of a fault. In the confidence analysis window, the results of the signature amplitude calculation and the confidence calculation are plotted in a scatter plot. The signature amplitude is normalized relative to the threshold values and is plotted vertically, and the confidence value is plotted horizontally. The plot is populated with the most recent amplitude-confidence pairs for each signature in the database. This is different from the scatter plot available in the spectrum data view. That plot contains only historical points for the specific displayed trend. There are three types of signatures: emergent, persistent, and direct. Rolling element bearing signatures are emergent signatures because the spectral lines are not present when the bearing is in good condition and begin to emerge from the spectrum as a fault develops. Some other signatures, such as imbalance or gear mesh, are persistent signatures, since even when the component is in an acceptable condition, these spectral lines are present. The two classes of signatures are displayed in separate scatter plots, which can be selected in the combo box above the scatter plot. Other signatures, such as temperatures, overall vibration amplitudes, and kurtosis values from time series averages, are direct signatures and have no confidence analysis. The plot currently selected is the emergent plot. Hovering over a point gives the name and values for that point. If the specific point is associated with a machine element in the watch list, the point is solid black rather than hollow blue. This helps in identifying important signature trends that may be new and not previously evaluated. At the right there are four regions: probable fault, warning, alert, and alarm. A signature point is considered good if it falls outside these regions, and will have the status of the region if it is located inside that region for a configured consecutive number of times. The four corners of the scatter plot correspond to different possible situations. Points in the bottom left are signatures with low amplitudes relative to alarm thresholds and a low confidence. These signatures are in a good status. The probable fault region contains signatures with low amplitudes relative to their alarm thresholds, but a high confidence. These points are assigned the probable fault status and require immediate attention. These signatures, if left unattended, would be missed alarms in a typical monitoring system, since their alarm thresholds are too high to alarm even though the confidence analysis indicates that the signature fault is present. The user should analyze each of these points and adjust alarm thresholds as necessary to monitor the developing fault. The top right corner contains signatures with high amplitudes relative to alarm thresholds and a high confidence. These are true faults and should be watched carefully to avoid machine failures. The top left corner contains signatures with a high amplitudes relative to alarm thresholds, but a low confidence. The confidence analysis does not detect a fault, but the amplitudes are above the thresholds. Points fall in this area if the thresholds are too tight, or if the signature trend amplitude is high because of some large interfering spectral peak. These thresholds should be evaluated and raised if appropriate. The best way to use this plot is to examine the positions of the points and identify ones you think are worthy of special attention. If you right-click over a point, you'll get a View Data menu item, which allows you to view the data for that point. Often, when there is a component fault, several signature trends go into alarm. So there's a family of points all identifying the same fault. This point is bearing 550, outer race fault, and this point is 550. If you double-click the point will be added to the list box at the far right. If you select that entry in the list box, the corresponding point has a large black dot. To see the family of points associated with this fault, right-click on the entry and select Highlight All Signatures for this measure. All associated signature points for this fault will be identified by larger points in the plot. That way you know which ones to concentrate on when evaluating bearing 550. You notice there is another group of points above the current selection. These are from bearing 450U. Let's do the same thing. Add it to the list by double-clicking on one of the points. It is now clear that all these points are 450U. Once you've examined the data and have determined that the machine element has a developing fault, you can add it to the watch list. Sometimes points are positioned very close to each other, making them difficult to analyze. Press and hold the left mouse button while dragging the mouse to define a zoom rectangle. This resizes the plot to make it easier to distinguish the points. When done, open the toolbar by moving the mouse above the solid line at the top of the plot. You can select Restore Previous Scale or Auto Scale X and Y to change the scale back. In addition to the emergent scatter plot, which is a plot of the most recent state of the bearing trends, there is the persistent plot. This plot is composed of persistent signatures, which are shaft, gear, and a few other fault types. You'll notice there's no probable fault region. Probable fault doesn't really make sense for persistent signatures because often points will fall in this corner even when the machine element is in good condition. The same alarm logic applies as for emergent signatures. The status of a point is determined by where it falls in the good, warning, alert, or alarm regions. There's a third type of scatter plot, the advanced plot. Here you can precisely select the criteria for inclusion in the plot based on many factors, such as machine type, component type, analysis type, etc. This would be used for advanced applications where you're studying particular phenomena. The database contains thousands of signature trends. The confidence analysis is a data mining tool to identify particular signature trends needing attention, saving the exhaustive inspection of every trend. Points in the probable fault region are usually early faults where the threshold should be evaluated and possibly lowered. Points in the upper left corner should have their thresholds evaluated because the thresholds are possibly too low. It is good practice to regularly tune the thresholds by using this tool to identify which signature trends need adjustment.